Hi, so today I'm going to be going over a dead 820 3115 motherboard. When I plug in the charger, it doesn't turn on at all. So let's just get a DC in board here and plug it in so that you can see what's going on and we can go over how it's troubleshooted. Now, it's the end of the day and I'm a little bit more tired than I usually am at the end of the day, so I'm probably not going to go over as much as I usually go over, but I am still going to fix this on camera and it's going to get humbled and you'll get to see how. So the first issue that we have here is that there's no green light on the charger. Now, if you've been watching this video series for any period of time, what's the first power rail that I need to check if there's no green light? The first power rail that I need to check is going to be PP3V42_G3hot. Please watch my video series on what is PP3V42_G3hot and why must it show up first? Or how does PP3V42 differentiate from PP-G3hot? So PP3V42 is 0 volts. Also keep in mind, look at this. PP-G3hot, which is supposed to be 12.6 volts on this board, right now is 0.775 volts. Now you may think to yourself, if you measure PP-G3hot first, this is a common mistake, I need to check PP-G3hot first because that's the first power rail on the list in the schematic diagram. So if I open the schematic diagram here, and I go over to page 3 or 7 or 8, I think it's 8. Here we go. If I open the diagram here, and I show you the diagram on this page, what you're going to see is that the first power rail up here is PP-G3hot, whereas PP3V42 is down the list, which makes no sense because PP3V42 has to show up first. So why are they listing it 6th? I'm not sure. So the most common mistake people are going to make is they're going to start troubleshooting PP-G3hot instead of PP3V42 first. The reason you have to troubleshoot PP3V42_G3hot first is because the circuit down here that creates PP-G3hot, again, we're getting advanced here. You should only be watching this if you've been watching for a long time. Go over my other videos if this is getting confusing where I explain everything a little bit more clearly. This chip, which creates PP-G3hot over here, this buck regulator controller, is going to turn on when the SMC tells it to turn on. The SMC is going to talk to it on a data line called SM bus charger SDA. That data line is created by pull-up resistors on the PP3V42 line. Further, the SMC itself on this machine is powered by PP3V42. So if you go over to page 3 on the schematic diagram, you'll see that the charger creates PP3V42, which goes here, which then goes over to the SMC. So without PP3V42, we're not going to get anything done. So let's figure out what's keeping PP3V42 from being created by searching for U6990, which is the page on the schematic for PP3V42. Now, once we're here, we're going to check every step of the way and try to get an idea of what is happening. So over here, we have where 2 different sources can power PP3V42. Remember that PP3V42 needs to be the first rail to show up. So why does it have 2 different sources? Why is PP-G3hot there as well as the charger? I said that PP3V42 has to show up first, so why would PP-G3hot be the input to the PP3V42 power supply? I'm glad you asked. When you plug in the charger is going to create PP-G3hot and PP3V42 simultaneously. However, if the charger is not plugged in, let's say the computer is running off battery power, PP-G3hot is going to be the only power source in the machine. That does not have to be quote-unquote created by the charger or the charging chip because it's simply coming from the battery. So if I go over to where U7000 is on this board, notice that PP-G3hot can be provided by this buck regulator over here. So the charger's 18 volts will be turned into 12.6 volts for the system using the buck regulator. This is the chip over here. This is what has to talk to the SMC before it turns on. And if the charger's not plugged in, then you have the battery providing power on PP-G3hot. So when you look at U6990 over here, what I want you to see and notice is that there are 2 different sources. So let's check R6990 over here and let's see what's going on. So if I go, before I even check that, I'm going to check for a short to ground on PP3V42 by finding the PP3V42 point on the board, which I can easily do over here. Let me just open up the board view for this model motherboard. I'm going to open up the board view software. So let's get the board view open. All right, now I'm going to find where PP3V42_G3hot shows up, and it's going to be down here. Now, I'm going to check right now with the multimeter. I'm going to take my red probe, put the red probe on ground, put the black probe on where PP3V42 is, and I get 0.304. That's not a short. I get no short on either side of L6995. L6995 is going to be this coil over here. So now we're going to check voltage every step of the way. So let's see if on R6990, do I get power? Is power going into this circuit? Fucking ceiling light. Doesn't... Oh, well. I'll read the voltage to you. You're never going to be able to see it. So what I'm going to do over here is measure. 16 volts going in on the other side of the resistor. 12 volts. 12 volts. On the other side of the diode, on D6990, 12.3 volts. All right, so something is definitely pulling this down. So, see this over here? I have 16 volts here, but then I have 12 volts here. So let's see what the resistance of R6990 is. Is R6990 good or is R6990 blown? R6990 is supposed to be 47 ohms, and according to my multimeter, it's 47 ohms. So that's not our problem. Now something is going to be pulling that power down. Perhaps a short to ground? Well, you never know. That's what our microscope and alcohol is going to be for. Now, if there's a short to ground in any component on that line, and here the only component, let's face it, is either U6990 or C6990, if there is any type of short to ground here, what's going to happen is you're going to have a lot of energy going through that component because the electricity is going to want to go to ground very, very badly. So we're going to take a look here. You could look at my videos on what is a short circuit if you don't know why electricity would want to go to ground. So I'm going to turn on the microscope camera here, which means I have to plug it in. Great job, dumbass. How about you plug it in before you switch over to it? Come on. Turn on. There we go. So I'm going to plug the charger in at this point. Let's see if you can tell me which one of my components is shorted. Oh, fuck stick. Yep. It's the PP3V42 regulator. So U6990, which is the PP3V42 regulator. See this over here? That's U6990 right there. So we're going to take off U6990 using the hot air station. Let's turn on the hot air station. Let's turn on the fume extractor. And we rip this off the board. Remember to be nice to the RAM slot. The RAM slot is right next door. It doesn't like excessive heat. Okay. Get all that lead-free solder sucked up onto my iron there. Way too much in the middle, which is I always fucking do that. And too much flux to piss off the electrical engineers. And now I find a scrap board to pull the chip off of, just in case I haven't pissed off everybody in the engineering community. You should Google yourself someday. My receptionist Googled me like 2 months ago, and man, dude, the amount of people that hate me that I've never met or talked to is astounding. It's pretty cool, though. Now the most important thing is to get it flat in the board. So I don't care if I put too much solder on the center pad because I can always just push down and get it flat in the board later. But that means that you have to keep track of the little solder balls that come out afterwards. Think of it like a video game. Okay. Okay. Get over here. Get over here. Alrighty. Now, let's see if that was the cause of my short. If it was the cause of my short, when I plug this in, the fan will spin. Bam, baby. Alright. Ugh. This board looks like it's been pissed on. Every board I get looks like it's been pissed on.